In today's modern world, drones are used for many reasons, including filming, military surveillance, and recreational activities. Drones fall under an intersection of aerospace, robotics, and mechatronics. They can range from entirely autonomous military-grade drones to your average remote-controlled drones that you might see a kid flying in the park. Another name for drones is unmanned aerial vehicles, or UAV. These machines are primarily used in situations where the conditions are too dry, distant, dull, or dangerous for human pilots. However, the term drone can be highly misleading, as there are many different kinds. Today, we will be talking about popular drones available for recreational use. The first and most important part of a commercially available drone is the frame. Frames are typically made from plastic or carbon fiber and can be arranged with different arm variations. The end of each arm houses the motor and propeller, while the center holds the flight controllers, gimbals, and other electronic gear, such as cameras. Most of the weight should be at the center, as this leads to the best flight characteristics. Weight matters, as the heavier the frame, the less lift can be achieved. However, you also don't want a super lightweight frame that will break upon impact. Carbon fiber is preferred for its strength and minimal weight. Next are the motors. There is a separate motor for each blade or arm. Motor decisions are based on required power and what you want the motor to do. If a multi-rotor is being built to carry heavy payloads and maintain the best possible flight times, then a slower spinning, higher torque motor is ideal. However, you may want an aggressive, fast system with lots of maneuverability and faster spinning rotor systems. Propellers are the wings of the drone and can be made from plastic or carbon fiber. Carbon fiber is the more durable choice, but it's also more expensive. The size of the propeller should also match your intended purpose. If you wish to have a more aggressive build, choose smaller propellers. The opposite is true for higher payload, longer flight time builds. The power of the drone comes from its batteries, which come in a wide variety of weights and capacities. As the capacity of the battery increases, so does its weight. There is a certain point where more capacity is no longer beneficial, and the benefits begin to diminish. The system that controls the drone is the electronic speed controller, which will run the motors you have. Since the motors are constantly spinning at different speeds, they need a speed controller to dictate that speed to them. If the motors all ran at the same speed, you would always be hovering. The transmitter and receiver help in communication between the drone and the person controlling it. The transmitter transmits the signal, and the receiver receives it. The receiver is connected to the flight controller. It delivers these inputs and then outputs the responses to the motors. The algorithm and codes built into the flight computer take all of your directions into consideration and apply the necessary power to each propeller to achieve smooth and controlled movement. Now, the next time you go out to fly your drone, you'll know exactly how much planning and delicate technology is involved.